Welcome to the Digital Multimeter Basics training. The goal of this training is to review the testing equipment we use in the field and make sure everyone understands the proper process for verifying absence of voltage before work begins. Even for experienced electricians, it's always important to revisit these fundamentals. A lot of electrical incidents happen not because someone doesn't know how to use a meter, but because a step gets skipped or the process isn't followed consistently. So today we'll go through the meters that are issued, how they're used, and the correct procedure for confirming that equipment is truly de-energized. Today's training is focused on a few main areas. First, we'll introduce the Fluke 17B digital multimeter and the Fluke T6-1000 electrical tester, which are the primary test instruments issued for use in the field. We'll also talk about the Fluke PRV240 proving unit, which is used to verify that your meter is working properly before and after testing. Another important part of this training is reviewing the live-dead-live testing procedure, which is the standard method used to confirm absence of voltage during lockout-tagout. Finally, we'll cover some general safety guidelines when using electrical testing equipment. Before using any test instrument, it's important to understand how that device works and what its limitations are. The Fluke 17B digital multimeter is a versatile meter used for a variety of electrical measurements, but like any tool, it's only effective if it's used correctly. You should always be familiar with the layout of the meter you're using, where your dial is, where the test lead plugs in, and what each setting is designed to measure. If you're unsure about a function or setting, the safest approach is to stop and consult the manufacturer's documentation or ask someone who is familiar with the equipment. Using a meter incorrectly can result in inaccurate readings, and when we're verifying whether equipment is energized or not, accuracy is critical. The rotary dial is what allows you to select the type of measurement the meter will perform. In most field situations, the functions electricians will use most often are measuring voltage and checking continuity. Voltage measurements are used when verifying whether a circuit is energized or de-energized. Continuity testing is typically used when checking whether a circuit path is complete, such as verifying connections or identifying break in conductors. It's important to make sure that the meter is set to the correct function before testing. Selecting the wrong setting can result in incorrect readings or potentially damage the meter. Take a moment to verify the correct setting before performing a test is a simple step that helps prevent mistakes. The Fluke PRV240 proving unit is used to confirm that your meter is functioning correctly. This device provides a known voltage source, typically around 240 volts, which allows you to test the meter and confirm that it's reading accurately. This step is essential because if the meter fails or a test lead is damaged, it could incorrectly indicate that a circuit is de-energized when it is not. By using the proving unit before and after testing, we verify that the meter was working correctly during the entire testing process. This is a key part of the live-dead-live procedure, which we'll talk about in more detail in a moment. The Fluke T6-1000 electrical tester is another piece of equipment that may be used in the field for electrical measurement and troubleshooting. One of the main advantages of this tester is its open fork design, which allows it to measure current without disconnecting conductors. It can measure AC voltage up to 1000 volts and current up to 200 amps. This tester also uses field sense technology, which allows current measurements to be taken without direct contact with the conductor. This can make troubleshooting faster and reduce the need for additional connections when diagnosing energized circuits. When performing lockout-tagout, verifying absence of voltage is a critical step before work begins. Even after equipment has been locked and tagged out, it must still be tested to confirm that no voltage is present. This is where the live-dead-live testing procedure comes into play. It's also important to remember that when performing voltage testing, employees must wear the appropriate arc flash and shock protection PPE for the equipment being tested. Testing does not involve exposure to electrical hazards, so proper PPE is required during the verification process. The first step in the LiveDead process is verifying that your meter is functioning properly. Start by turning on the PRV240 proving unit and selecting the appropriate setting depending on whether you are testing AC or DC voltage. Then place the test leads from the Fluke 17B onto the terminals of the proving unit. Your meter should display a reading of approximately 240 volts. This confirms that the meter is functioning correctly before you test the circuit. Once the meter has been verified, you can move to the equipment that has been placed under lockout/tagout. Use the meter to test the circuit and confirm that the reading shows 0 volts. After confirming that the circuit is de-energized, the final step is to return to the proving unit and test the meter again. The meter should once again read approximately 240 volts. This final check confirms that the meter remained operational during the testing process and that the absence of voltage reading was accurate. To finish up, there are a few safety guidelines that should always be followed when using electrical testing equipment. Always inspect your test leads and equipment before using them. Damaged leads or faulty equipment can result in inaccurate readings or increase the risk of electrical shock. Make sure you're wearing correct arc flash and shock protection PPE for the task and the equipment being tested. Follow company procedures and refer to the manufacturer documentation whenever needed. And if there's any questions about testing equipment or procedures, reach out to the safety department for guidance. Proper testing procedures help ensure that electrical work is performed safely and that hazards are identified before work begins.